Suppose a sample of 500 is used to estimate the fraction of voters that favor a particular candidate. If the population proportion that favors the candidate is really 0.4, what is the probability that the error of estimation will be less than 0.05? Okay, I've got a lot of proportions thrown around here. Ultimately, this is a probability question. So let's start, let's kind of do another quick read and kind of catalog what we know. Well, it said there was a sample size of 500. So that'll be our N. And the proportion that really favors the candidate, if we knew that, that would be our population proportion here, as it mentioned, would be 0.4. Now, I can't help if I've already here, Q will also be involved in this, and that's 1 minus P, which is 1 minus 0.4, which is 0.6. So I'm reading that as 40% of people prefer this candidate and 60% of voters do not prefer this candidate. So we have P and Q. And then what is the probability that the error of estimation will be less than 0.05? So when I see the word probability, I'm thinking area under the curve. And so I'm going to draw my normal model here, putting our population proportion at the center. And I'm going to need area under the curve because of probability. And it says the error of estimation will be less than 0.05. So I think we're going to go to the left, what we will call 0.05, which go back to 0.35. We'll go to the right the same distance and call that 0.45. So we'd like to know the area of this region here that I've shaded. And that will be our answer. So we have most of everything we need. We have the center of the distribution we can give to Rguroo. What we don't, and we have stopping points along the axis where we'll draw lines and declare shading inside or outside of. What we don't have is our standard deviation. So that will be the square root of P times Q over N. For us, that is 0.4 times 0.6 over 500. So let's go to Desmos, which is inside of Rguroo, and do this small calculation we've just written. So square root of 0.4 times 0.6 all over 500. Here it is to the right there, 0.0219. I'm going to go up to about 3 decimal places, so let's call that 0.022. So this value is approximately 0.022. So the things we're going to have to tell our software, let me just kind of highlight them. We're going to need to give it the middle of the distribution there as the mean, the standard deviation, of course. And then also we're going to give it, just using some different color here, that we want the area to be between 0.35 and 0.45. So let's keep that in mind. Those are the numbers we're going to share with software. Alrighty, let's get to our probability simulation pane here on the left side. Probability, go to the calculators, staying with continuous. We've been using the normal model. So values to probability, perfect, normal is the default. We set our mean to be 0.4, our standard deviation to be 0.022. And we got to pick a between here because we shaded between 0.35 and 0.45. So that's that error being 0.05 to the left, or it could be 0.05 to the right. Let's hit preview, and we get a probability 0.97696. So pretty high, right? That it's going to be within 0.05, almost 98% chance. Let's look at a picture real quick. Let's pick graph so that I can see it. Going to zoom out just a little bit, a little easier to see. If I scroll up here, you can see there it is, exactly what I want. This is why I draw pictures from 0.35 to 0.45, centered there at 0.40. And, it repeats back to me the mean and standard deviation up here. Mean is 0.4, standard deviation is 0.022, and there is my probability. So if I go back to my picture, I can write this probability. The area between the two is 0.977, I believe. Let me double check that. That's what happens when I go 977, of course. And that's the answer.